What we're going to take a look at here is finding trig values for our common angles. This is definitely an important concept, and it's really foundational for everything that we do in the rest of this section when we graph and really moving forward, just understanding where these values come from. And really to start, where they all start is 30, 60, 90 triangles and 45, 45, 90 triangles, which you guys had learned back in geometry. Just a quick review. I know it's kind of tough to see here. We have a 30, 60, 90 triangle here. The important thing to remember is the ratio of the sides. That across from 30 is 1x, across from 60 is root 3 times x, and across from the 90-degree angle is 2x. And all of that makes sense. Across from the smallest angle should be the smallest side. Across from the intermediate angle should be in the intermediate side, and across from the largest angle should be the largest side. And that would be the 30, 60, 90 triangle. Now down here, what we're looking at is a 45, 45, 90 triangle. Across from the 45s is 1x, and they should be the same exact side length because they're the same angle. And then across from the 90 would be the largest side length, which would be square root of 2 times x. So what we're going to work with for all of these examples, we're going to assume that x is going to be equal to 1 for everything that we do. So the first one that we look at is going to be 30 degrees or pi over 6 radians. So if we go through and we draw an angle where this is true, starting from the initial side here, 30 degrees is going to be somewhere around there. And what we end up doing is we go through and we put in a 30, 60, 90 triangle. So if we put in a 30, 60, 90 triangle, that side would be 90, over here would be 30, and up here would be 60. Now we use the side ratios and understanding where they are in relation to the triangle here. Across from the 60 should be root 3, across from the 30 should be 1, and across from the 90 should be 2. Now we actually go through and we identify what sine of theta is equal to and what cosine of theta is equal to. And there's two ways to do that. The first is by using the definitions of sine and cosine. And if we're looking at that, remember x would be how far we moved in the x direction, y would be how far we moved up in the y direction, and then r is going to be our hypotenuse, which is really just the radius of the circle here, from the middle to the intersection of the circle here. So that would just be our radius. So going through and looking at this, our y value here is 1, and our hypotenuse, or our radius, is 2. So that means sine of theta, or I'm sorry, I should say sine of 30 and cosine of 30 is equal to 1/2. Now cosine of 30 should be our x term, which would be root 3 over our hypotenuse, which is 2. Now what some people like to look at is they see this and they think back to geometry and they think about SOHCAHTOA. And what all that stands for, SOHCAHTOA, the sine of our angle is going to be opposite over hypotenuse. Here's our 30-degree angle. Our opposite side was 1. Our hypotenuse was 2. There's 1 over 2. Our cosine should be adjacent, which is root 3, over our hypotenuse, which is 2, which ended up coming out to be true for both of those. And really, we're going to end up going through and doing the same concept for the next two. We have a 45-degree or a pi over 4 radian angle. What that's going to look like is something along those lines. And the same idea as before, I'm going to go through and I'm going to draw in now a 45, 45, 90 triangle. That side would be 90, and both angles here would be 45 and 45. So, looking at what we had seen before, our ratios. Across from the 90-degree side is square root of 2. Across from both 45-degree angles is 1. So, now I can go through and figure out what my sine and cosine values are going to be. The same sort of way. Y over r in this case would be 1 over the square root of 2. And when we look at that, what we don't like is the radical in the denominator, so we have to get rid of that. To do that, what we multiply by is square root of 2 over square root of 2, or rationalizing the denominator, because now when we go through and we do this, we'll have square root of 2 over 2, which is much nicer to look at. We got rid of that radical on the bottom. And we're really going to go through and do the same thing with cosine of 45. I'm going to look at x, in this case, is 1, and my radius is the square root of 2. Same exact process as for sine, and I would have square root of 2 over 2 again. So what that's telling me is my sine of 45 is square root of 2 over 2, cosine of 45 is square root of 2 over 2. And what all of that means, even up here as well, that means the point right here is going to be root 2 over 2, comma, root 2 over 2. Okay, this point right here, when we make a 45-degree angle and that intersects the circle, we're going to have the point root 2 over 2, root 2 over 2. Up here, what that point would end up being. What we have to remember is all of our points are cosine theta, sine of theta. Sine relates to y, cosine relates to x. So when I go through and I do this, my cosine value was root 3 over 2. So this point would be root 3 over 2, comma, 1/2. My sine value is root 3 over 2. My y value, or my sine value, is 1/2. So that means this point right here ends up satisfying those conditions. Last one, same sort of thing as above. We have a 60-degree angle, or pi over 3 radians, which is going to look like this. But really, all that is it's a 30, 60, 90 triangle that we had worked with before, just kind of turned. Here's our 60-degree angle, so this side over here should be square root of 3. This side should be 1, and then that side should end up being 2. So I really go through and I do the same exact things that I had done before. Sine of 60, and figure out cosine of 60. Sine of 60 would be y over r, root 3 over 2, and our cosine of 60 would be x, which is 1, over r, which is 2. So what that's telling me is this point right here is going to be x comma, cosine comma sine, which would be 1/2 comma root 3 over 2. Those would be the trig values there. Now, those are going to be important for finding trig values across the entire circle. That's really the fundamental part of those. And there's another video for that that's already up on my YouTube channel for those. But we'll come back to that in a second. There's one other kind of important trig value that we got to look at. Points that are on the x and the y axis. So when I look at these, what I'm talking about, this point here, this point here, this point here, and this point here. Points that are on the x or y axis that intersect our circle. So by definition, our unit circle has a radius of 1. So what that's telling me is if this is the point 0, 0, which it is, middle of our unit circle, and I've gone 1 unit this way, because this is basically my radius right here, basically 1 here. What that's telling me, this point over here is going to end up being is 1 comma 0. I've gone 1 in the positive x direction, 0 in the y direction, so I should have 1, 0. Up here, that would make this point 0 in the x direction, 1 in the positive y. This point, starting at 0, 0, I go 1 to the left. So although our radius is still 1, sorry about that, little power outage. Even though our radius is still 1, we're going in the negative x direction, so what this point should end up being is negative 1 comma 0. And then the bottom point should end up being 0, negative 1. So if I were to go through and find my sine and my cosine values for all of these, I'm just going to go ahead and I'm going to use the x and the y coordinates that I had seen before. So for example, sine of 0, sine relates to y. So my y value here is going to end up being 0. So my sine of 0 is going to be 0. Cosine of 0 is going to be the x coordinate. It's just 1. Now 90. When I look at 90 here, sine is my y coordinate. My y coordinate here is 1. My cosine is going to be my x coordinate. In this case is 0. And the same thing happens throughout the rest of the circle. If I do sine of 180 and I do cosine of 270, sine of 180 degrees, what that's going to be is my y coordinate at 180 degrees, which is 0. Cosine of 270, what that's going to end up being, down here, my x coordinate is 0. And I could continue this. I could say sine of 270, what that's going to come out to be is the y coordinate at 270 degrees, which is negative 1. Okay, all of those things, again, our sine value relates to the y coordinate, and the cosine value relates to the x coordinate. And it was the same thing that we had seen over here. And just by definition, that should make sense. Just based on definition, that, ignore the chart, if cosine of theta is going to equal x over r. And in our unit circle, our r value is just 1. That means cosine of theta should just equal x, which is exactly what we're saying. In our coordinate x, y, x is just going to be cosine of theta, and the same thing can be said for y, just by definition making r equal 1, that our y value is going to end up being sine of theta. Now, this chart that we see in class all the time, this is where we get the values from. So, looking at up here, when I said sine of 0 equals 0, that's where that came from. And cosine of 0 equaled 1. And what we had also just found is sine of 90 equaled 1, and cosine of 90 equaled 0. And then what I'm going to use are the values from this page, which I found, sine of 30, cosine of 30, sine of 45, cosine of 45, sine of 60, cosine of 60, and I'm going to end up filling all of those in here. You know, that's where all of these values come from. Root 3 over 2, root 2 over 2, ends 1/2. Oh, I don't even see it. Alright, that's where all those values come from. What this is saying is the y-coordinate at each of these angles is whatever we have listed here. The x-coordinate at each of these angles is going to be each of those numbers listed along the bottom here. And really, this is what you're going to end up using when we find trig values, and that's in another video, which you could also watch on my channel.